Hello, my name is Saidiksha Arvind, and today I am going to explain the Big Bang Theory and how astronomical evidence, especially light spectra and the composition of matter, supports it. The Big Bang Theory is currently the most accepted scientific explanation for the origin of the universe. It proposes that the universe began about 13.7 billion years ago, from a state that was incredibly hot, dense, and small. Then it suddenly expanded and began cooling down over time. This wasn't an explosion in space, it was an expansion of space itself. We know that the universe is expanding because galaxies are moving away from each other. And not just that, the rate of expansion is increasing. This means that the space between galaxies is stretching and is happening faster and faster. Scientists believe that this is caused by something called dark energy, a mysterious force that makes up most of the universe's energy. This constant expansion is one of the major clues that the universe had a beginning point, what we call the Big Bang. Another key piece of evidence comes from light spectra. When light travels through space from distant galaxies, it stretches out. This stretching causes the light to shift toward the red end of the spectrum, something we call redshift. If a bang launched all matter outward, we would expect to see this redshift because light from objects moving away from us gets elongated. Its wavelength increases, showing up as red light. This is exactly what astronomers observe. To go a little deeper, when a galaxy moves away from us, its light waves get stretched out, resulting in redshift. On the flip side, if something were moving towards us, its light waves would compress and we'd see a blue shift. But across the universe, we mostly see redshift, which tells us that galaxies are generally moving away from us. This supports the idea of an expanding universe and points back to a time when everything was much closer together, like the Big Bang. Now, how do we know how fast the universe is expanding? That's where the Hubble's law comes in. It states that the farther away a galaxy is, the faster it's moving away. This relationship between distance and speed lets scientists calculate how long the universe has been expanding, so how old it is. Edwin Hubble's work gave us direct observational proof that the universe is expanding, just like the Big Bang Theory predicts. One of the strongest pieces of evidence for the Big Bang is the cosmic microwave background, or CMB. This is faint microwave radiation that fills the universe like the leftover heat from the Big Bang. It's extremely uniform, meaning it has and looks the same in all directions, and it has a perfect black body spectrum. That's exactly what we'd expect to see if the early universe was hot and dense and then cooled down as it expanded, just like the Big Bang states. Next is the composition of matter in the universe, what everything is made of. Scientists find that hydrogen and helium are by far the most abundant element in the universe. That is not random because this matches predictions from the Big Bang Theory. These light elements formed in the first few minutes after the Big Bang is called the Big Bang nucleosynthesis. Big Bang nucleosynthesis, or BBN, explains how light elements like hydrogen, helium, and a little bit of lithium were formed when the universe was just minutes old. As the universe cooled, protons and neutrons started combining to form atomic nuclei. This process could only happen during a narrow window of time when the conditions were just perfect. The amounts of these elements we observe today match exactly what the theory predicted. So why are light spectra and element ratios so important? Because they give us two completely different but consistent lines of evidence and reasoning that both point back to the Big Bang. Redshift in light spectra shows the universe is expanding and has been expanding ever since it began, and the ratios of hydrogen, helium, and other light elements match what we'd expect if those elements were created early in a hot, dense universe. Together, they help us understand what the universe was like at its beginning and how it's changed over time. To sum it all up, the Big Bang Theory explains how the universe started and evolved. We know this because of redshift in light spectra, which proves galaxies are moving apart, and because of the specific mix of elements in space which formed shortly after the Big Bang. Plus, the discovery of the cosmic microwave background gives us a direct look at the afterglow of the Big Bang, sealing the case. So when we put all of this together, redshift, element ratios, the CMB, and the universe's expansion, it forms a powerful argument. The evidence tells us a consistent story. Our universe had a hot, dense beginning and has been expanding ever since, just like the Big Bang Theory states. Thank you.